The world of AI is moving so fast, it's almost impossible to keep up. And the language around it, well, that's changing just as quickly. So if you really want to get a handle on where all this is going, you've got to speak the language. That's what we're going to do right now. Let's break down 7 key AI terms you absolutely need to know.
Okay, I know what you're thinking. An AI toothbrush? Sounds a little weird, right? But honestly, this quote just perfectly nails where we're at with AI today. This stuff isn't some far-off sci-fi concept anymore. It's here. It's now. It's in our cars. It's on our phones. And yeah, you guessed it. It's even in our toothbrushes.
So yeah, AI is basically everywhere. And because things are changing so ridiculously fast, just keeping up with the lingo can be a real challenge. And that's true even if you're deep in the tech world. That's why we're doing this, because learning the language is the very first step to really understanding the technology that's, well, reshaping our entire world.
All right, first up, let's talk about the doers. These are the AIs that don't just chat with you, they actually go out and get stuff done. This is all about action and the thought process that drives it. So our first term is agentic AI. You've probably been hearing this phrase thrown around a lot lately. Think about a simple chatbot. You give it a command, it gives you a response. End of story. An AI agent is completely different. You can give an agent a big picture goal, something like, hey, plan a weekend trip to Miami for me, and it won't just list some flights. It'll actually reason, plan, and execute all the steps to make it happen. It becomes your personal travel agent or a data analyst or even an engineer that fixes system problems on its own. This is a huge shift from AI as a simple tool to AI as an autonomous collaborator.
So, how does it actually do all this? Well, it all comes down to a constant cycle called the agentic loop. Step 1, it perceives its environment. What's going on? Step 2, based on that, it thinks. It reasons and plans out what to do next. Step 3, it takes action. It actually does the thing. And finally, step 4, it observes the outcome. Did it work? That result feeds right back into the next loop. It just keeps doing this. Perceive, reason, act, observe, over and over, learning and adapting until the job is done.
Okay, but that brings up a really important question. We see the agent doing things, but how is it thinking? What's happening under the hood? What's actually powering that reason and plan step we just talked about?
Well, that's where our second term comes in, large reasoning models, or LRMs. You can think of these as the specialized brains inside the agents. They're fine-tuned on problems that have clear, correct answers, like math and code. And here's the key. Instead of just spitting out an answer, an LRM generates a chain of thought. It literally talks itself through the problem step by step to figure things out. This means it's way more likely to land on an accurate, well-reasoned solution. It's not just guessing, it's reasoning.
Okay, so we have agents that can think and do. But where do they get their information from? I mean, an AI is only as smart as the data it has access to, right? So next up, let's talk about the knowledge piece of the puzzle. First, let's tackle vector databases. This is a really fundamental shift in how we store information. See, a traditional database just holds raw files, text documents, images, that sort of thing. A vector database does something totally different. It takes a piece of data, text, a picture, even a song, and turns it into a long string of numbers called a vector. And here's the magic. That vector doesn't just represent the data, it represents the meaning of the data. That's a huge difference.
The process itself is actually pretty straightforward. You take an input, say this picture of a cat. You feed it into something called an embedding model, and out comes that numerical vector we were talking about. And that vector is basically a mathematical fingerprint for the concept of cat. It captures the catness of the image in a way a computer can actually understand and compare to other concepts.
Here's a really simple way to think about it. A traditional database is like a library organized alphabetically by title. A vector database, on the other hand, is like a library organized by meaning. All the books about adventure are in one section. All the books about philosophy are in another, no matter what their titles are. You can see how this lets you do incredibly powerful searches based on ideas, not just keywords.
And all of this leads perfectly into our next term, RAG. It stands for Retrieval Augmented Generation. In a nutshell, RAG uses these powerful vector databases to make large language models a whole lot smarter. Think of it like giving the LLM a cheat sheet with all the most relevant, up-to-the-minute information before it tries to answer your question. This is how you stop an AI from giving you stale, outdated answers.
Okay, so here's how it works. Step 1, you ask a question. Before the LLM even sees it, the RAG system zips over to its vector database and pulls out all the most relevant info. Then, it takes that good stuff it found and basically staples it to your original question. So now, the supercharged, context-rich prompt gets sent to the LLM. And because it has all this extra, relevant context, its answer is going to be way more accurate and detailed. It's a total game changer.
All right, so we've got AIs that can act and AIs that can tap into vast amounts of knowledge. Now let's talk about a couple of key upgrades that are making these systems better connected and way more efficient.
First, we have the Model Context Protocol, or MCP. Look, for an AI to be really useful, it can't be stuck in a box. It needs to connect to things, databases, APIs, maybe even your email. MCP is basically a universal adapter for AI. It creates one standard way for any model to connect to any external tool. This is huge for developers because it means they don't have to build a new custom connection every single time. It's like plug and play for AI.
Next up is Mixture of Experts, usually just called KNOW. This is a really clever way to build gigantic AI models without them being ridiculously slow and expensive. Instead of having one huge know-it-all model, an MOE architecture breaks it up into a bunch of smaller, specialized experts. When a request comes in, a smart router looks at it and says, okay, for this task, I only need to activate these specific experts. The doctor analogy is perfect. You don't talk to every doctor in the hospital for a broken arm. You just see the specialist. Mo works the same way. And that right there is the magic of Mo. You can have a model with a staggering number of parameters. We're talking trillions. But for any single query, you're only using a tiny fraction of them. So you get the power and knowledge of a massive model, but with the speed and efficiency of a much smaller one. It's an absolute game changer for building powerful AI efficiently. Okay, for our last section, let's zoom out and look at the future. We're going to talk about two terms that you hear all the time that are often confused and that really point to the long-term endgame for AI. First, there's AGI, or Artificial General Intelligence. The goal here is to create an AI that can perform pretty much any intellectual task that a human expert can. This is kind of the holy grail that many researchers are working towards. But then you have ASI, Artificial Superintelligence, and this is a whole different ballgame. An ASI wouldn't just be as smart as a human, it would be vastly, incomprehensibly smarter. And crucially, it would be able to improve itself, getting smarter and smarter at an exponential rate.
And that's where things get pretty profound. On one hand, an AI could be this incredible force for good. It might solve humanity's biggest problems, like curing disease or fixing climate change. But on the other hand, it could also create brand new, existential risks that we can't even begin to wrap our heads around. Now, this is all still theoretical, of course, but the stakes are so high that it's a concept we absolutely have to be aware of.
So there you have it. We started with the doers, Agent AI and LRMs, then the knowledge, RAG and vector databases. We looked at the upgrades like MCP and MOE, and we wrapped up with the future of AGI and ASI. These terms are the building blocks, the language you need to understand where AI is today and where it's headed tomorrow. Now that you've got these concepts down, you have a much better framework for understanding the next big headline or breakthrough that comes along. But that just leaves us with one last question, doesn't it? This field is moving so fast. A whole new vocabulary is probably being written as we speak. So, what do you think? What will be the next must-know term that defines the future of AI?